Hello everyone, it's Daniel from TechMind Factory. Welcome to this next video from the series called Modern Identity powered by Azure. In this video, we are going to talk about delegated and application permissions in the cloud applications secured by Microsoft Identity Platform, so Azure AD and Azure AD B2C. So let's start. If you watched my previous videos, you probably remember that I mentioned that there are two methods that applications use to authenticate with Microsoft Identity Platform. It can be delegated access, so an application is acting on behalf of signed-in user to access specific resources. So in this scenario, this is like a typical scenario. So you have web application where user can click login button, user is redirected to the Microsoft Identity Platform, so Azure AD/Azure AD B2C SIAM login page. User provides credentials and then user is redirected to the web application with the set of tokens like ID token, access token or refresh token, and then using the access token, user or application calls web API in the context of authenticated user. So in this case, we talk about delegated access. But on the other side, there is application only access. In this case, an application is acting with its own identity without any user context to access specific resources. So in this case, application authenticates itself to the Microsoft Identity Platform, and then application can access specific resources like APIs again, but without any context of the user. Above two methods define how an application accesses the data. So let's talk about it. So let's start with delegated access, so access on behalf of a user. User authenticates in the application secured by Microsoft Identity Platform, so Azure AD or Azure AD B2C, to access resources secured by Web API. So in this case, it's a typical scenario where there is web application or mobile application, user clicks login button, user is redirected to the login page of Azure AD or Azure AD B2C, user provides set of credentials, and then once the authentication is successful, application obtains tokens, ID token, access token, and refresh token. And now it's also very important to mention that before application can obtain the set of tokens, the application has to ask the user to grant specific permission, so to consent. So this is why in this video we are going to talk about consents also, to make sure that we understand how this mechanism works. But anyway, to continue, because of the app and the user must be authorized to make the request, the resource, so for instance the web API in this context, grants the client app the delegated permissions for the client app to access data on behalf of the authenticated user. So in this case, it means that before application can even call some API, in this context resource, application has to obtain the access token first, and to obtain the access token, application has to ask the user to consent and to grant the permission to allow application to contact this resource in a context of authenticated user. Now, delegated permissions are also called scopes, and those allow the application to act on behalf of signed-in user. So in this case, when we call identity provider from our web application, so Azure AD or Azure AD B2C, we define scopes, and then we say which permissions application needs to, like contact resource like web API and get the data in the context of authenticated user. So now let's look at this diagram. So there is a user, and user has to authenticate within the application. And obviously this application is secured by Microsoft Identity Platform. So Azure Active Directory or Azure Active Directory B2C or SIAM. So Once the user is successfully authenticated, application then can access protected resource on behalf of authenticated user, so using the access token. So in this case, application can call the web API, provide the access token in the authorization header, and obviously then web API will return some data related to a specific user. Great. There is very important rule, so least privilege rule. Applications must only request the permissions they absolutely require to function. So it's very important because basically it's very typical and common to ask for more permissions than it's required for application to function in the context of the user. So it's very important to look into those permissions, to validate them, review them, and decide whether specific application should ask for the set of permissions or not, because maybe it's too much. Great. So when we talk about those permissions, and I also mentioned consents, there is user consent and admin consent. So let's talk about those two. When it comes to user consent, it is used for accessing a specific user's data. So in this case, user has to consent, agree that specific application will access specific resources in context of this specific authenticated user. The user can allow or deny. So when we authenticate, probably if you try to authenticate using Azure Active Directory, you saw this consent screen. Like there is this question: application would like to access your basic profile, read your email, or send emails on behalf of you. And you can accept or you can deny. If you accept, obviously application will get the access token, and then with this access token, application can call the resource, so Web API or Microsoft Graph, and then proceed with set of operations. If you deny, there is no token return, you will be redirected to the application. Obviously, it has to be handled properly, but then, this access to the protected resource is not granted. Admins can restrict or even disable user consent. So it's very important, like obviously administrators can control the consent behavior for users and applications. So when it comes to administrator consent, it's for significantly high privilege permissions. So in this case, we talk about really high privilege permissions that application needs. And for those set of permissions, administrator of Azure AD has to consent and grant those permissions to the application. Those are broad in scope. So for example, sites that read .all or user read all. So in this case, we are not talking about the single user identity, but also we talk about reading more data from the tenant, like reading all user profiles in this context. And as I mentioned, it's outside of specific user context. Yes, example is user.readWrite.all. So in this case, administrator has to consent because yes, it's more than required in a specific typical scenario where we only need to access the profile of authenticated user, not all the users in the Azure AD tenant. Perfect. So right now, let's talk about delegated permissions declaration. So applications request permissions in the source code of the app when calling Microsoft Identity Platform authorization endpoint. So either Azure AD or Azure AD B2C authorization endpoint. Permissions can be requested using three ways. So basically, the first one is to statically request permissions. So in this case, during the user authentication, we will just display all the permissions required by the application, and user can either consent or just cancel the operation and disagree and decline to grant those permissions. The second option is to dynamically ask for permissions. So during the authentication, we are asking only about the basic set of permissions, and I will show you that in this video in a minute. And also, we can ask for permissions incrementally. So at the beginning, during user authentication, we can ask for a set of permissions for the application, basic permissions. But then when using application to access specific functionality, we need, let's say, like higher privilege permission. So then we have to ask the user about it. So in this case, incremental consent is used. And I will show you that in a minute. Here are some examples of delegated permissions. So for instance, user.read allows users to sign in to the application and allows the application to read the profile of signed-in users. It also allows the application to read basic company information of the signed-in users. Another permission can be user.read-write. Allows the application to read the signed-in user's full profile, and it also allows the application to update the signed-in user profile information on their behalf. And obviously there are more permissions, delegated permissions available in the Microsoft Identity Platform. Great, so right now we understand permissions. Yes, like application asks for a set of permissions from the user. If those permissions are granted, then application can call specific resources to obtain data. But when it comes to requesting those permissions, like there is a specific name for that. So it's called user consents. So in this case, when we click login button and we are redirected to the identity provider where we provide set of credentials, then there is this window displayed, as you can see currently on the screen. Like this application would like to view your basic profile, maintain access to data you have given it access to, send mail as you, and so on. So user consent happens when a user attempts to sign into an application by providing credentials. So this screen is always displayed in the authentication operation for the applications secured by Azure Active Directory. And these credentials provided by the user are checked to determine whether consent has already been granted by the user. If no previous record of the user or admin consent for the required permissions exists, the user is shown a consent prompt and asked to grant the application the requested permissions. So this is exactly the screen you can see on the right side right now. In many scenarios, administrator may be required to grant consent on behalf of the user because of high privilege permissions. So this is what we talked about before. Yes, maybe those permissions are high privilege permissions. So in this case, Azure Active Directory administrator should consent. Okay, so I mentioned 3 types of consents. So let's dive into those consents types to make sure that we understand them. First of all, dynamic consents. Permissions that every user will need to use application. So those are those basic permissions I mentioned required for the application to function, to provide basic functionality, to authenticate user, to get basic data from different kinds of resources, web APIs. So in this case, every time user authenticates, those permissions are requested if they were not granted before by the user. They must be accepted during authentication. This is what I mentioned. Yeah? And examples of such permissions are mail.read or mail.send. So in this case, user is asked to grant those permissions to make sure that application can, for instance, send email in the context of authenticated user. On the other side, we have incremental consents. So permissions requested as the user needs them. And that's the difference, because you can try to imagine that requesting for all the permissions at the beginning during first authentication of the user can be not a good experience for the user. Yes, so in this case, user can be quite confused why this application would like to access all those different permissions and so on. So when it comes to incremental consents, they are not required to be accepted during authentication. Certain permissions may scare off users at the beginning, so it's good to request these permissions only when needed. So this is exactly what I mentioned. Like, okay, we can authenticate and use application with basic set of permissions. But for instance, if we need to access all the files and read them from specific application, then we can access for additional permission. Then the consent screen will be displayed. User has to accept or deny, obviously, and then application get the permission to access higher privilege resources, let's say. And also the third consent type is static consent. So those consents are related to all permissions declared for the application in the Azure Active Directory. So when we declare those permissions in the Azure Active Directory portal under API permissions tab, we add different permissions like mail.read-write, mail.send, and so on. So in this case, when it comes to static permissions, during the authentication, when we use static consents, all the permissions will be displayed and user has to either accept or decline. And the scope is different when calling from the application. As I mentioned before, in the application code, we define scopes. So in this case, to use static consents, we are using the default scope. So in this case, for Microsoft Graph permissions, for instance, we have to provide this scope like graph.microsoft.com/default. And then once user would like to access application, user has to consent to all the permissions that will be displayed on the screen specified for this specific application. And yeah, when it comes, there is one more note. Default scope triggers a consent prompt only if the user has not granted permissions for the app to the resource, yes, in the past. So it's very important to mention that. Now, on the other side, there are administrator consents. So some applications might require an administrator to be one who grants consent. Many high privilege delegated permissions can only be consented to by an administrator of the tenant, of the Azure AD tenant. It's very important. So in this case, when we would like to use specific permissions within our application, only Azure AD administrator can grant them. It's very important. And if we open Microsoft Identity Platform documentation with permissions for Microsoft Graph, for instance, we will see where admin consent is required. Administrators can grant consent for themselves or for the entire organization. It's also important. So, as you can see in the picture presented here, when I use administrator account to authenticate in the application, there is this checkbox displayed, consent on behalf of your organization. Yeah, so I can either consent on as me, as administrator, without selecting this checkbox, and I can just click accept button and it will be granted only on behalf of me and myself, administrator. Or if I select this checkbox, then I consent on behalf of the organization. So in this case, when any other user will try to sign in, all those permissions will be automatically granted. So the consent screen will not be displayed. Okay, great. So what about Azure Active Directory B2C? So in Azure AD B2C, there is no support for dynamic user consents. All permissions must be granted by the tenant administrator. It's very important. So you will not see consent screen when signing in to the applications secured by Azure AD B2C. All those permissions, once they are declared under API permissions tab for a specific application registered in the Azure AD B2C tenant, all those permissions has to be granted. So grant admin consent button should be used by the tenant administrator. Also, when it comes to Azure AD B2C, it's quite, I would say, different scenario, because Azure AD B2C is for the customers, yes, for the applications used by end customers. Azure AD B2C is not used for the corporate scenarios. So in this case, the terms of use approach is used instead in the Azure AD B2C. So user must accept terms and conditions on the sign up page. So that's the difference, yes. Before accessing the application, we can display terms of service with the link to the PDF file, for instance. and user has to agree to terms of service, and then user account is created. So that's the difference. That's another approach used in the Azure Active Directory B2C. Okay, so right now let's talk a little bit about effective delegated permissions. So when talking about delegated permissions, we said that applications get access on behalf of users. And those can be different kinds of applications: mobile, single page applications, web applications, desktop applications, yes, many other applications. And when it comes to permission type, is delegated permission, so the user permission. And when it comes to consents, users can consent of their data, but also, as we mentioned, administrator of the tenant can consent for them or for all users. That's also very important to be mentioned. And now we have effective permissions. So it's like intersection between delegated permissions, so those permissions declared for the application to ask users to accept, and also user privileges. So what user can do in a context of specific application within a specific context. Yes, so in this case, this is this intersection. So basically, remember that application cannot do more than user is privileged to do. That's very important when it comes to delegated access. So it's always this intersection between user privileges and delegated permissions granted to the application. Perfect. So now let's talk about application-only access, so the access without the user's context. In this scenario, an application can interact with data on its own without assigning user. So there is no user context. This type of access is used in scenarios such as automation and backup, and is mostly used by applications that run as background services or daemons. So in this case, it's very important to underline there is no user context. Those applications are background services. And you can try to imagine that there is, for instance, Azure function with time trigger, and this function is triggered every, let's say, 12 hours, and this function has to authenticate to the Microsoft Identity Platform, obtain the token, and then call some set of APIs to synchronize the data and fill out the data in the database. So there is no user context, but still we have to secure this access. Yes, so in this case we will need application access, so this application can access resources without the user context. When application is assigned application permissions, these are also called uproles. Yes, so in this case, to make sure that application can call a secure resource like Microsoft Graph, we have to declare application permissions, not delegated permissions for the users, because we mentioned that there will be no user context. Let's look at this simple diagram. So in this case, there is no user. Application authenticates directly to Microsoft Identity Platform. So in this case, we use client credentials flow typically. So client ID and client secret has to be provided to Microsoft Identity Platform, or instead of using secret, we can also use certificate. But still, it's about the application identity. Once application is authenticated, application obtains access token, and with this access token, application can call secure resource, so web API in this context. So let's talk more about application permissions. So application proofs, it is the app requesting permission using secret, certificates, manage identity for Azure resources. Yes, as I mentioned before. So in this case, we can decide how to do it. Obviously, the recommended way is to use manage identity for Azure resources when possible. Certificates is also a secure option and recommended option. The less recommended option is to use client secrets for applications. And also, when it comes to application permissions, admin consent must be always granted. So in this case, we always have to click this grant admin consent button under API permissions tab for our, let's call it, daemon application, to make sure that this application will be able to obtain access token to call protected resources. Okay, great. So right now let's look at some application permissions examples. So it can be, for instance, user.readwrite.all. So this permission allows application to update all user profiles in the Azure AD tenant, obviously without the user context. So application obtains access token and then can call Microsoft Graph to update any profile of the user registered in the Azure AD. But it can be also calendars that read. So application is allowed to read all calendars in the tenant. Obviously, there are many more application permissions, and those are available in the official documentation. Those are some examples, but again, in the documentation, we will see that is explained what exactly specific permission provides and enables. Okay, and again, when it comes to effective application permissions, let's discuss them really quickly. So first of all, we said we getting access as a service. Yes, there is no user context. When it comes to application type, it can be web application, background service, daemon, but basically this is the application that is authenticating as itself without the user context. When it comes to permission type, it's application permission. Who can consent? Only admin can consent. Again, no user. And when it comes to effective permissions, those are just app permissions. So once they are granted by administrator of the tenant, then application can obtain tokens to call secure resources. The last one thing I would like to mention is publisher verification, and it's also related to consents. Because it's displayed when consents are presented to the user. So publisher verification helps to understand the authenticity of application developers. It's used to increase transparency and risk reduction for the customers. It provides improved branding and smoother enterprise adoption. So in this case, if we are ISV, for instance, so independent software vendor, and we provide some applications secured by Azure Active Directory, in this case, it's good to use this publisher verification because then users feel more comfortable when accessing those applications because they know that, okay, this specific organization and tenant was verified with Microsoft. Perfect. So right now, let's see it in action. So I prepared a small demo for this video. So let's jump into the Visual Studio. Here is the Blazor server application I prepared. And when it comes to consents experience and the flow I will show you, it will be exactly the same. It doesn't matter which kind of app you use, like it can be web application, single page application, desktop application, mobile application. When it comes to consents, it will look exactly the same. So here is my web application. Obviously, it's registered in the Azure Active Directory tenant, and we will see it in a minute. But the case is that I can use this application to sign in and then to do different things. And the case is that in this specific video, I would like to show you 3 different kinds of consents. So static consent, dynamic consent, and incremental consent. So let's start with static consents first. So let's jump into Microsoft Entra admin portal where I have this application registered. Here is my application, and under API permissions tab, as you can see, I added 2 delegated permissions. Mail.readWrite, so read and write access to user email, and mail.send, so send mail as a user. So in this case, once user consents and user accepts those permissions, application will be able to read and write user mail, and also application will be able to send emails, obviously on behalf of authenticated user. So when user authenticates, first user has to accept, has to consent. And once a user accepts those requested permissions, then application obtains the access token. And with this access token, application can access secure resource, so Microsoft Graph in this case, and can proceed with the operation, like for instance, can send an email in the context of authenticated user. So right now, let's get back to the Visual Studio to see this experience. But before we will do it, please also note that admin consent is not required for those permissions. Yes, so in this case, users, standard users registered in the Azure AD can just consent and agree that they will grant this set of permissions to the application. Okay, so let's see the demo. In this specific application, I use Microsoft Identity Web Library, and in the app settings.json file, I have the configuration for this application. So the name of my tenant, the tenant ID, client ID of the application registered in the Microsoft Entra portal. I have client secret, but also, as you can see, I have the scope. So in this case, let's start with static consents. So in this case, the scope will be graph.microsoft.com/.default. It means that during user authentication, all the permissions will be requested, all the permissions declared in the Entra admin portal for this specific application. So mail read write and mail send. So in this case, user has to consent to all of requested permissions at once, and then user can start using the application. So let's see this experience. So let me launch the application. Here is the application. I will click login button. I'm redirected to the Microsoft Identity Platform, so Azure Active Directory. I have to provide my email, also my password for the user, and as you can see, here is the consent screen. So those are the permissions requested by the application. Because of the fact that we use static consents here, application is requesting all the permissions that we declared in the API permissions tab for this specific application registered in the Microsoft Entra admin portal. So as we can see, application would like to access our mailbox, read and write. Application would like to send email in our context, and application would like to sign in and read our profile. So here I can either accept, and then I will be redirected to the application with a set of tokens. But also I can click cancel. If I will click cancel, which I will do right now, I will be redirected to the application. And as you can see, I'm not authenticated because application was not granted those permissions. And in the end, yeah, there is no token generated for the application. So just to summarize, when it comes to static consents, those are the consents that will display all the permissions declared for our application registered in the Azure Active Directory. And when it comes to static consents, we can use them when we need all the permissions to be granted by the user at once during first authentication. But obviously, the better solution would be to use incremental consents and ask for the permissions only when required when it comes to application functionalities. Great, so right now, let me show you dynamic consents, and then I will show incremental consents. So right now, let's see the dynamic consents. First of all, to use dynamic consents, we have to change the scope parameter in the application configuration. So we will not use default scope anymore for static consents. We will use mail.send scope in this case. But before I will launch the application, please remember that for this specific application in the Microsoft Entra admin portal, I specified two delegated permissions, mail.readWrite and mail.send. But in this case, I will only request mail.send permission for this application. So let's see it in action. So again, here is the web application. I will click login button. And again, I'm redirected to the Azure Active Directory authorization endpoint. I have to provide my login, my password, and now, as you can see, there is a request to access my basic profile, obviously, together with the permission to send mail in the context of authenticated user, so in my context, basically. But as you can see, there is no request for reading and writing mailbox. Yeah, in this case. So there is only the permission displayed and consent for the permission that I declared in the scope parameter in my application configuration. So this is why it's called dynamic consent, because even if I declare those API permissions, those permissions under API permissions tab in the Microsoft Entra admin portal, and I said like I want to use those set of permissions, when requesting, when calling authorization endpoint, I can describe which permission I would like to obtain for the application. So in this case, I declared mail.send, and this is why I see the consent screen with the information that application would like to send mail as myself. So basically there is nothing mentioned about mail that read-write permission in this case. Perfect. So right now you can try to imagine the situation that, let's say you accepted those permissions, you consented, and then you need other permission declared for the application. So this is where we can use incremental consents. So in this case, at the initial authentication operation, during the initial authentication operation, there is a request for those permissions you can see currently on the screen. But maybe if we would like to use some of the features, advanced features, let's say, in the application, we will need more permissions to be granted by the user. So in this case, we can use incremental consents. So let's see how to do it. To test incremental consents, we will use mail.readWrite permission declared for the application. So as we saw in the application configuration, still the scope is mail.send. But maybe we would like to call for more permissions. We need more permissions from the user. So this is why right now we are going to ask for mail.readWrite permission to be granted by the user. So in the source code, as you can see, I have consent handler declared. And basically, this is the object of the class provided by Microsoft Identity Web Library. So it's very helpful to use Microsoft Identity Web Library because it provides many helpful classes and interfaces to be used. Another thing I have here is token acquisition. Here, so it's the instance, it's the implementation of the interface called iToken acquisition, which is also provided by Microsoft Identity Web Library. And now, if I scroll down here to the onInitialized async method, you can see that when the page will be loaded, I would like to get access token for the user again. So get access token for the user async method is used on token acquisition instance. But here I will request mail.readWrite scope. So in this case, I need this permission to be granted by the user. And basically when application and underneath Microsoft Identity Web Library will verify whether this permission was granted or not when calling Microsoft Identity Platform. And if this permission was not granted by the user during the authentication, there will be Microsoft Identity Web Challenge user exception thrown. So to make it more simple, when we try to get access token, with this specific mail.readWrite scope, but we know that user did not consent, so not granted permission to read-write mail, then the exception will be thrown. And then with consent handler, we are going to handle this exception. So in this case, we will display consents page again to the user, and then user can obviously grant this permission or decline, but once the permission is granted, then we can get the access token to read-write mail for the specific user. So let's see it in action. Let me open application window. Here is the web application. I will click login button again. I'm redirected to the authorization endpoint. of Azure AD, I have to provide credentials. And once I do it, I'm authenticated. No consent screen displayed because previously I accepted consents. So in this case, application has access to my basic profile and application can send emails on behalf of myself. So I'm redirected to the application and it works perfect. There is a greeting at the top, hello Daniel. But then let's say that I would like to access Fetch Data tab, which requires more permissions to be granted from the user. So as you remember in the source code, we said that when we will open this specific tab, we will request for the access token using the mail.readWrite scope. So let's see what will happen. I will click Fetch Data. And right now, what is happening, application tried to get the access token from the Microsoft Identity Platform, from the Azure AD. But Azure AD verified that user did not consent to read and write mail read-write permission. So this is why consent screen is displayed again to the user, and user has to either accept, so consent, or decline. So it's very important. Like as you can see, the first permission is the permission we are requesting, read and write access to your mail. So in this case, this is incremental consent, because as you saw at the beginning when I authenticated, I was not asked to grant the permission. And once I access the Fetch Data tab in my application, then I'm requested to consent. So if I will click Accept, then I can obtain the access token and then I'm redirected to the application. So this is about the incremental consents. So let me show you just one last thing in the Microsoft Entra admin portal. If you open Enterprise Applications tab in the Microsoft Entra and you select the application that you registered, so in my case it's Blazor Server, and you will open Permissions tab and switch to User Consent tab, you will see all the permissions declared for the application, but also you can see who granted this permission. So if I will click Mail Read Write and granted by, I can see that it was granted by Daniel Tester. So here we can review all the granted permissions by specific users registered in our Azure AD tenant. Great, so that's it for this video. Thank you so much for watching and I hope to see you in the next video.